Yeah, thank you, guys. A brief introduction. I'm Boyan from Manta Network. I'm working on the cryptography. So today I will talk about zkLottery. I mean, zkLottery is not anything related to my work. I mean, to my job. It's done during this hackathon. So don't expect too much. I mean, I don't have any front end. Yeah, because I'm only the single person. Yeah, so. Mm, Okay, so why should we care about zkLottery? Because there is an increasing popularity of lottery to promote the event participation. Actually, I mean, after I come to East Denver, one of my friend, he is holding some events with like several, hundreds or thousands of people coming, and he asked, "Hey, boy, do you know any, I mean, the lottery mechanisms that can be used for, Web3 conference, right?" So I mean, that's why I have the motivation to build this zkLottery. Actually, there are, many existing approaches. The first one is we have a lottery box, right? We have a lottery box, put everyone's name inside it and grab one, right? This is a very traditional way. Another thing is like a lottery machine, or like you have a laptop, you wrote your Python code, you can draw a lottery in, I mean, very, very fast. But there are many issues with these two existing approach. One is the fairness, right? Whether the lottery is fair or not. Like, hey, if I draw a lottery for a very fancy car, people always say, hey, the winner must be some, some people from this company. This kind of story. Yeah, also there are some privacy concerns I can talk about later. Yeah, so basically that's why we want to build a zkLottery using zero-knowledge proof. Is fully on-chain on the smart contract. Okay, so we have on-chain lottery for fairness. Basically, we can the high-level idea is to have an on-chain storage of all the participants at certain block number 1, and after a certain time, like block number 2, I mean, it's in the future, then we do the on-chain lottery, right? Because we don't know some randomness in the future. Yeah, that's a very high-level idea. So actually, we can use the randomness from the future block hashes because we cannot know the block hash of a future block, right? And so the question is, hey, suppose I want to draw multiple prizes instead of one, what should I do, right? If I only want to draw one, I can just take the block hash of future block, then do some, modular over the number of participants. I can get an index, right? I can get the name, email, all the thing. But what if I want to draw 5 or 10 lottery, right? Should we wait for 5 or 10 blocks? This would be, not so good. So actually, we can use one thing called CHF is cryptographic secure hashing function. So basically, it means, hey, giving the input, you cannot. It's very hard to. I mean, the output have no relationship with the inputs. That's why it's called cryptographically secure. And so basically, in this case, we can just take the block hash at the block number 2 until it's predefined when we deploy the contract. It's the future when we deploy it, right? We can take the block hash as H1, H0. Then we feed it into the catch-up hash on the Ethereum Solidity contract. It's very efficient. It's about like 50 gas something. It's very fast. It's very efficient. We just keep doing this catch-up hash n times, then we can draw whatever number of lotteries we want.
You mean we're applying catch-up hash for H0?
Yes, good catch. Yeah, H0. Okay, the whole workflow should be we first deploy the contract on the chain for this specific event. We have the on-chain storage of all the participants. We specify a future block number n. Then we draw the lottery after this block n, so we can use all the stuff we have described earlier. And I can show you very this kind of like the detail. So basically, you see we require at this line 51, we require, hey, the block number has actually passed the specified target block number. It's the future. If we call this draw lottery before, it does not work, right? And also we have this prefix, so it's different for every event. Also we have some, basically, okay. One thing I want to mention is here at, oops. One thing I want to mention is here at line 63. Actually, I found one thing interesting is, although this cryptographic hashing is 256 bit is super long, usually we cannot find any collision, right? However, because we want to because we want to take a index from this hash value. So basically, this index is some very small number between 0 to 2000, probably, according to the number of users, right? So there might be some collision. Yeah, actually, I found it. I mean, yeah. So basically, we just keep trying, draw until we find enough different participant for this lottery. Okay, so basically, when we use it, it's super simple. We just once we deploy this contract, we can just call this draw lottery. It will automatically print all the winners, like this one, right? Basically, I store all the user email on the blockchain. Okay, sounds good. But one thing is there is a privacy concern because we leak user information on chain. We store all the information on blockchain. We know who participates in this event, right? It's not so good. Yeah. So basically, how should we solve this problem? Okay, zk helps for the on-chain privacy. Yeah. So basically, whenever you need some privacy stuff on the blockchain, I would say most cases you can use a zero-knowledge proof to solve it. Yeah, basically you don't need to put the data on the blockchain. You can pass some basically this data is your secret. You can pass some hash value, some stuff on the blockchain, so other people cannot know what does this hash value means, right? And also other people cannot find secret that generates this hash value. So basically other people cannot claim the rewards for you. Yeah, so zk is very helpful. And so in this case, the workflow would be slightly different. So basically during the registration, we ask users to run a hash function. It probably is a catch-up function on their like the email or whatever stuff. Then they do the then we can do the on-chain lottery based on these hashes, right? So on-chain we can only see the hash. There's nothing leaked, right? And once we find the hash, there would be a selected hash on the blockchain. People knows, hey, this hash value have the reward, but people do not know what does it means for, who should receive it, right? So basically, in this case, as a winner, I can do the in-browser proof generation to show, hey, I actually knows the secret that leads to this hash value, right? Only I know, because I mean during registration I run this hash function to generate the hash and pass it, right? So I just need to remember this secret and now use it for zero-knowledge proof generation. Yeah, any question? Okay. No. Okay.
How are you generating the in-browser proof?
Yeah, I would say, I mean, Circum is really useful. Yeah, so basically, yeah, awesome. Yeah, awesome. Yeah, yeah. Probably you can also use like JavaScript, whatever language, to generate the proof. You only need to have a a zk framework. I mean, it should support browsers, and it's fine. Yeah. Okay, cool. So once you generate this proof, you can pass this proof to the smart contract, and on the contract will verify this proof and see if it generates the hash value or not, right? If it can, then the contract will send the reward to whatever address you are using when you send this proof. Okay, yeah, so you can create a new Ethereum address, use it to send the proof and claim the reward. No one knows who you are. Okay, yeah, that's all for my presentation. Yeah, thanks. Any questions? Please.
Okay, so maybe it's lack of understanding on my part, but I'm not understanding exactly the value of zk here, considering that the whole infrastructure works without zk. But now the usage of zk that you have is for privacy, right? Just so we don't know who is participating in the raffle.
Yes.
But what you're doing is that to enter the raffle, you put any information, so it's like a password basically, that the user inputs into a hash function, and that's the hash function that you store in the blockchain.
Yes.
Right. So why do you need zk in at this moment? Because for example, to retrieve my prize, wouldn't I just be able to pass my password again? And you check if the password won on the blockchain, and just like if this is the hash that won on the blockchain, if my password hashed is the same as the hash that won on the blockchain, hence I'm the winner, hence I received the money.
Yeah, that's a very, very interesting question. So when you say you check the secret, what do you mean by you? Is it the company, the conference event holder, or the blockchain?
No, what I mean is like, you check is just like when we're using the service, so basically the smart contract.
Yes.
You're passing to be able to enter your raffle, you're hashing my password,
Mm-hmm.
and you're putting it on the blockchain.
Okay, so
Then one password is selected, like one hash is selected and selected as user. Now, if I want to retrieve my prize, wouldn't I just be able to pass in again my password, hash it, and you check it, like if my my hash is the same hash that won, and now you say, okay, this guy won. And basically you could do this.
okay, so you are saying let's say if you send your secret directly to the blockchain, basically yourself leaves your privacy, leaves your data on the blockchain. Anyone can see it, right? Other people knows, hey, this is the email that should receive the reward, right?
But then how do you store it in the first place? Like where like in the first place, when I enter the raffle, how do you secure that?
Yeah, so basically, let's say, so you can have a smart contract and we can have a register function. And every time you just send this hash value to this register function, the register function will add you into the list of all the participants on the contract. So you do not need to send your secret to me or the contract, right? So this can saves your privacy.
Okay.
Please.
So right now it's kind of a broader label product.
Yes.
So we're looking at the mobile label things.
Probably yes. So technically yes. The ZK in this case is very, very small. Yeah, we can definitely build for mobile. Yeah, actually, I feel this might be very useful for many, conference. So I probably will, build more open sources so people can use it.
So you said any framework, so like Snark.js or something would work?
Yeah.
Just a question on what's your thought on the semaphore and trying to use kind of a project?
Okay, yeah, semaphore is great. It's really great. It's for the private voting, but it's slightly different from the lottery, I would say. Yeah, semaphore mostly prove, hey, I am a member of a certain group, and I also vote for something or send some secret signal, right? But this case is like, hey, I joined some lottery pool.
Thank you, guys.
Thank you, guys.
Great projects, and thank you so much for presenting. Thanks so much for being here. Hackers, the testers, everyone. Thanks so much. And right, so I mean it's more than 2 hours to be honest. So let's just relax, get some food and some drinks and get to each other.
And thanks for the organization. I can-